Hello everyone, welcome to my channel. In this video I have a couple of very interesting integrals that I would like us to go through, and I invite you to stop these videos, go through these questions, and let me know your feedback in the comment section. Now if you're new to this channel, please support us by subscribing. So our first integral is the integral of 8x minus 1 all over open brackets 2x minus 1 close brackets squared dx. Now these are extremely advanced cases of u-substitution. If you try to use partial fractions here, you will end up taking a very long period of time. But there are tricks. That's why these are called techniques of integration. There are tricks that we apply in these integrals. So this one here has its own trick that I'm going to show you now. Taking us to page 1. Let me capture the question. That's page 1 here. The question is number 1, the integral of 8x minus 1 all over 2x minus 1 all squared dx. Now watch what I'm going to do here. I'm going to let u be equal to 2x minus 1. Couple of things to do with this equation here. The first one is as follows. We are going to differentiate u with respect to x. So du dx, you'll agree with me that the answer is 2. Now multiplying both sides by dx, we get du is equal to twice dx. Dividing both sides by 2, you'll agree with me that this is du over 2 and this is equal to dx. The reason why I am expressing dx in terms of du over 2 is because if you check here, we have dx, and so it is wise to have dx there, and this expression here will take the place of dx. But now the denominator is taken care of. We have a problem now with the numerator, so we have to construct the numerator from this equation here as follows. Now if you check, if you look at the numerator there, we have 8x minus 1. So I need 8x there. So I have to multiply both sides of this equation by 4. So I'm able to produce 8x there. The minus 4 will be taken care of as we proceed. So therefore, we are basically saying 4u is equal to 4, open brackets, 2x minus 1. Expanding this, we are saying it's 8x minus 4. Now, at least the first part is obtained. I need the minus 1. So I have to split the minus 4 as follows. Remember, 4u equals this. 4u is equal to 8x minus 1 minus 3. You agree with me that this is actually minus 4. So I'm going to take minus 3 and add, I'm going to take minus 3 to the left hand side, or add 3 on both sides as follows. So this is going to be 4u plus 3, and the answer is 8x minus 1. Now the whole thing is sorted. I have to perform triple substitution. We get rid of the numerator, denominator, and dx. So that integral now changes to, watch this, the integral of, in the numerator, I have 4u plus 3. In the denominator, I have u squared. And then in place of dx, I have du all over 2. Now this is wonderful. So I can take half out because it's a constant, 1 over 2, the integral of, and allow me to use term-wise division here. So I'm going to have 4u all over u squared plus 3 all over u squared, like that, dx, du. Now, so we simplify the expression in square brackets. Let me have another bracket here just to close this one here. Now taking us to page 2. Page 2. So basically, I am saying that so that integral simplifies to, let's have 1 over 2 outside, and let's maintain that. And now I'm going to have to distribute du. This part here is going to be 4 over u. du, and then we have to have plus 3 over u squared du. There you have it. Now let's work on this. Now I'm going to take 3 out because it's a constant, and I'm going to take 4 out because it's a constant. So this is 1 over 2. We're multiplying that by 4, integral of 1 over u du, and then we have plus 3, the integral of, notice 1 over, let me just take it the way it is, 1 over u squared du. Right, this part here we have 1 over 2 open brackets 4 natural log of u. Remember, the integral of 1 over u is natural log of u. And then here I'm going to have to say plus the integral of u to the power minus 2 du. And then I'm going to have to add 1 in the numerator and divide the result. But there's a 3 outside there, so don't forget that. So now what we have is 1 over 2, and then 4 natural log of u. And then we have to have here now it's going to be plus 3 u to the power minus 1 if you add 1 to that. And then we're going to take minus 1, divide there, like so. And then we're going to say plus a constant c. Now let's simplify this part. Let's clean up. Now this is going to be 1 over 2, and one step at a time, 4 natural log of u, and then this part will become minus 3 all over u, and plus c. Let's remove the brackets. Half multiplying, distributing half. You'll agree with me that this is 2 natural log of u, and then we're going to have minus 3 all over 2u, and then we have to say absolute value there plus a constant c. But remember, our original variable is x and not u. What is the relationship between u and x? Here we go. There it is, u equals 2x minus 1. So where there is u, I must put 2x minus 1, and then I'm done. So this is going to be equal to 2 natural log of 2x minus 1, and then minus 3 all over 2, open brackets, 2x minus 1, and then I have to say plus c. So this is the final solution to integral number 1. You can agree with me that this is actually brilliant, especially when it comes to the tricks that we have applied here to be able to evaluate this integral that looks very, very intimidating, and yet simple u substitution. Maybe one can argue and say not simple, but yeah, u substitution, reconstructing the numerator there in terms of u, and in performing u substitution, and we are at the solution to our integral, first integral, and our solution is over here. Right, let's move on to the second one. Very high order integration techniques. We're talking about u substitution here, very advanced cases of u substitution. I have integral number 2 now that I want us to look at. Here is the second integral, equally intimidating, as you can see. Now, how do we go about this? Well, same technique, u substitution. And on this one here, I'm just going to have number 2. I'll number the pages according to number 2, and then number 3, like that. So number 2, our solution, let's capture number 2 here. Some part of me says I must number the pages according to how we started. So page 1, page 2, this would be page 3. So this would be page 3. And we have integral number 2 over here. Let me recapture this integral over here. So it's the integral of x plus 3 all over cube root of x squared plus 6x, and then we have dx. Now that's the one we have here. How do we go about this? Well, if you look at the expression under the cube root sign, if I differentiate this, I'm going to get 2x plus 6, but I have x plus 3 in the numerator, so I have to change this to 2x plus 6 by multiplying by 2, but I don't want to change the integral, so I have to divide by 2 at the same time. So this is going to be watch this, 1 over 2, the integral of 2 open brackets x plus 3, and then I have cube root of x squared plus 6x dx. Now let me simplify this. This is going to be 1 over 2, the integral of 2x plus 6, and we're saying all over cube root of x squared plus 6x, and I'm saying dx. Wonderful. So now I can say, because of cube root here, I'm going to say let u cubed be equal to x squared plus 6x. Differentiating both sides, you will agree with me that this is going to be 3u squared du. On the right hand side, I'm going to have 2x plus 6, and then what do I have? Dx. Now this is nice because now this expression here, the 2x plus 6 in the numerator, can combine with dx as follows. Let me rewrite that so that you can clearly see how the substitution will take place. So this is half of the integral of 1 all over cube root of x squared plus 6x, and then I'm multiplying this by, watch this, 2x plus 6, and then we have dx. I'm combining 2x plus 6 and with dx, and then in the numerator I'm going to have 1 over down here. This is what I have. Now this is wonderful because if you can see, this expression here is that expression. So I'll have this part replaced by that, and in the denominator I'll have cube root of u cubed, and then we can carry on with integration. Let's go to page 4. Page 4, and basically I'm saying now we have a much easier integral to evaluate. So right now, moving forward, that integral changes to 1 over 2, and watch this now, the integral of 1 all over cube root of u cubed, and in place of 2x plus 6 dx, I'm going to have 3u squared du. You can see it clearly here, 3u squared du equals that expression, which is this part here. Now simplifying this, let me put this aside now. Simplifying this, what we have now is 1 over 2, the integral of, watch this, 1 over, this cancels that obviously, u, and we're multiplying this by 3u squared du. Take 3 out because it's a constant, and simplify, cancel u there, and that's what you have. So I'm going to have 3 over 2 now, the integral of u du. Now, integral of u, you'll agree with me, that is actually u squared over 2. Then we have to say plus c because we're dealing with an indefinite integral. Simplifying this part, you'll agree with me that this is 3/4 u squared plus c. But what is u? We must move back to our original variable. The connection, if you can check here, it requires us to take cube root in order to determine the value of u. So now solving for u here, you'll agree with me that this is actually producing cube root of u cubed is u, and then on the right hand side I'm going to have cube root of x squared plus 6x. Right now, so that's cube root of x squared plus 6x. This can be rewritten. Let me give you another page here. Basically, I want to look at this expression here, cube root of x squared plus 6x. This you can rewrite it as x squared plus 6x, and then we say to the power 1 over 3. That's cube root of that expression. All right, so now moving on, this part now is going to be 3/4, and I'm going to have the u alone is this expression, remember, x squared plus 6x, and we have to take cube root of that, in other words the power 1 over 3. So x squared plus 6x, the power 1 over 3, and the whole of this has to be squared and then plus c. Remember, we have a square u squared there. Simplifying this part, you'll agree with me that this is just 3/4. Let me move this one. This is just 3/4 of, watch this, x squared plus 6x to the power 2 over 3, and then plus c. This is the final solution to integral number 2, which is this one here. Second integral, that's the one. Looking very intimidating, but like I told you, we are employing very advanced techniques of u-substitution. Yeah, so this works out so nicely, producing our solution on page 4. Now I'm moving on to integral number 3, third integral in this video, taking us to page 5. The third integral is this one here, also looking very, very intimidating. But like I told you, these are extremely advanced cases of u-substitution. Looking at this one here, a couple of things must be done, and then we are going to use u-substitution. So let me rewrite the integral number 3. Like I said, this is page 5. The integral of 1 all over, integral of 1 all over 4 square root of x, and then we have square root of x minus 1, and we're told dx. Now I have to take 4 out because it's a constant, 1/4. The integral of 1 all over, I have to take square root of x to be under that. You will see why I'm doing that. Square root of x minus 1 times dx all over square root of x. Fantastic. Now I'm gonna let u squared, because of that square sign, the big one, u squared be equal to square root of x minus 1. I'm going to take the entire of this expression there, let it be equal to u squared. And I'm going to say that this, remember, is the same as x power half minus 1, and we are saying u squared equals that. Maybe it will be necessary at this stage to solve for u. You'll agree with me that u is going to be the square root of x minus 1. That's the value of u. We will need it at a later stage. But now let me differentiate both sides of this. I want to obtain the expression for the x over square root of x. So this will be, you'll agree with me, 2u du is equal to 1 over 2 x power half minus 1, and then I have to say dx. Now you agree with me that this is 2u du is equal to 1 over 2, and I'm going to say 1 over x power half, because this is minus half, and when you bring it down, the power becomes positive, and then we have dx, laws of exponents. Multiply by 2 both sides. This is going to be 4u du is equal to, rewriting this, you're going to get dx all over square root of x. This part here is that part there, as you can see. Now I have an expression for this, which is this one, an expression for that expression there under the square sign, which is u squared, and now I can move on. So that integral there, if I may squeeze it in here, is equal to 1/4 the integral of 1 all over square root of u squared, and in place of dx over square root of x, I have 4u du. Wonderful. Now notice something, this cancels that. So what do I have now? Moving on to page 6. Page 6 here, and our integral now is this one here. Okay, there you go. Which is looking very simple now. So we're saying that is, let me keep the 1/4 outside, and we're saying the integral of 1 over u times 4u du. Take the 4 out. Notice the u cancels, and in the numerator I'm going to have 4 times 1 is 4 over 4, the integral of, obviously, 1 du. Outside here I have 1, so the 4's cancel, and the integral of 1 is actually u, and I have to say plus c because this is an indefinite integral. But what is u? I told you, u is this expression there. So now my answer is square root of x minus 1 plus c. That's my final solution to integral number 3. Very interesting, actually. Looking intimidating, but with u-substitution and a little bit of cleverness there, we are able to evaluate this integral that's looking not so nice. Let's look at the fourth one. The fourth integral I have for you is this one here. Moving to the e world now, not looking very nice, I must say. So how do we go about this? Well, when we look at the expression under the square sign, we have e to the power x minus 1. In the numerator, I have 3, which is a constant. I can take it out. But e to the power 2x can be can be divided into or broken down into e to the power x times e to the power x. You say, why do you do that? Well, you'll see shortly. Remember, these are techniques of integration. You have to do a bit of work before u-Substitution can actually come out clearly as a technique of integration that should be employed. Page 7, integral number 4. Looking at time here, I think I'm going to make that one our last integral in this video here. So integral number 4 is 3 e to the power 2x. If I can go through this quick enough, I will try and bring up a fifth one. But yeah, let's try. So e to the power x minus 1, and then we have dx. Now, I told you that this will be written as 3, the integral of e to the power x times e to the power x all over square root of e to the power x minus 1 dx. Now, combining this and that, I will have 3, the integral of e to the power x all over square root of e to the power x minus 1 times e to the power x dx. Now, we're getting somewhere. I will now let u be equal to e to the power, actually u squared because of the square root sign, for x minus 1, differentiating both sides, 2u du is equal to e to the power x dx. Remember, derivative of 1 is 0 because it's a constant. That expression is that expression taken care of. I have this part here. And so e to the power x, we can solve for e to the power x from here. You'll agree with me that I will have u squared plus 1 is actually equal to e to the power x. We may also need u, working out u from here, you can see that u is in fact square root of e to the power x minus 1. We may need that one at a later stage. Now, rewriting this integral, therefore, we are saying that that integral should be 3, the integral of, instead of e to the power x, I'm going to have a u squared plus 1. So u squared plus 1 in the numerator all over. I have square root of, what is e power x minus 1 is u squared. What is e power x dx? It's 2u du. So 2u du. This cancels that. And so let's put down what we have. 3, the integral of u squared plus 1. In the denominator, I have u, and we're multiplying this by 2u du. Take 2 out because it's a constant and it's multiplying. So I'm going to have 6 there. And the u cancels the u. This cancels that. Let me put this in brackets. Take the 2 out. What do we get? Taking us to page 8, we get the following. We get, move this one down a bit. Hope you can see it there. Yes. So now, basically, I'm saying we now have 6, the integral of u squared plus 1, and then we have du. Now, this one here, we can go straight into integration or distributing this and the integral sign. We have 6. We have the integral of u squared du, and then plus integral of 1 du, like so. This is 6, integral of u squared is u power 3 over 3, and then plus integral of 1 is u, and then plus c. Removing brackets, you'll agree with me that this is just going to be 2 u cubed plus 6u, and then plus c. Now, what is u? Well, I told you we would need the expression for u. It's just the square root of e to the power x minus 1. So I'm going to have, and by the way, this one here, you can also rewrite. You get a page here that I may need to use. So much paper around here. Let me just get a page. So watch this. Basically what I'm saying is u is equal to square root of e to the power x minus 1, but you can rewrite this as e to the power x minus 1 and then we say power half, like that. So basically this is what I'm saying, that that expression there becomes e power x minus 1 power e power x minus 1, the whole of this to power half. So this is 2 open brackets e power x minus 1. We are saying this is power half, but it has to be to power 3, and then plus 6 e to power x minus 1 power half plus c. I'm going to rewrite this. This expression here can simplify to 2 open brackets e to the power x minus 1 power 3 over 2, and then we are saying plus 6 times that, which, if you allow me, let me keep it the way it is for now, e to the power x minus 1 power half plus c. I like to present this in an original way, or an original format, with square root sign. This will be square root of that cubed, and that will be square root of that. So this is basically 2 square root of, watch this, 2 times square root of e to the power x minus 1, this whole expression cubed, like that. And then we are saying plus 6 square root of e to the power x minus 1, then plus c. By the way, you don't get any extra mark by rewriting this expression here into that form. This form of the solution is sufficient, but yeah, whatever suits you would be would be the right way to go. I'm going to stop here in this video. Many more videos will come on integration. This is a very fascinating part of mathematics. If you're new to the channel, support us by subscribing. I will see you in the next video.